Okay, so I'm just going to start here. We have Matthew Schutte as the right. We have
I pronounce it Shooty, but we probably pronounce it wrong.
Okay, we have Matthew Schutte, Director of Communications from Holo, and we're just going to ask you a couple of questions for Crypto Ticker about the new Holo port. And yes, you can start by telling a little bit about yourself.
Sure. So, yeah, my name is Matthew Schutte. I work with a group called Holo. We've put out something recently called Holochain, which is an alternative to blockchain technology. And we'll go into more detail there maybe. And we're crowdfunding right now for the first real big application on top of Holochain, which is called Holo. And Holo is an incentivized hosting ecosystem. So Holochain enables people to run distributed applications, literally peer-to-peer applications. So you can do things like you could do a Facebook scale app just on the phones of the users. So 1 billion users, and they're just using their phones. Holo is something that actually enables those peer-to-peer applications to speak to the outside world, to speak to a web browser. And we think that Holo is a really important part of the ecosystem because it's going to make it a little easier for grandma to begin using the distributed applications of tomorrow. We want that on-ramp to be as easy as possible. And Holo includes within it an incentive structure so that some of the members of the community are actually incentivized to do the work of serving a website to essentially a visitor, to somebody who isn't a peer in this peer-to-peer community. And so it's sort of a bridge between the decentralized world or the distributed world of the future, or the emerging present, I suppose, and the centralized past. So it's something that's really about helping us foster a transition to a more distributed and empowering way of doing applications. For us, the focus wasn't on tech. The focus was on how do you make it so that individuals are in charge of their own lives? How do you make it so they're in charge of their data, they're in charge of their applications, and they get to essentially steer their digital lives? And so that's what we've been building towards, and we don't want it to just be like a Puritan fantasy. We want it to be practical and adopted. And so Holo is one of the key first steps in helping to start that adoption path for most people.
Awesome. You've mentioned the campaign that you're having at the moment. It's actually the very first time that I hear that a crypto company runs a Kickstarter campaign.
Yeah.
Why did you decide to go this way?
Sure. Well, our platform would be upset that you'd called it Kickstarter because we're listed on Indiegogo. But yes, they're one of their main competitors.
Oh, I'm sorry. I take that back.
They would be so offended. No. So why did we run an Indiegogo campaign? This is part of our fundraising strategy. So one of the things was we did not want to take funds from venture capital. We did not want to make promises to investors that we are going to give you these huge returns out of the equity of the organization. We are eventually planning to hand our community, the organization itself, over to the members of the community. That's the roadmap that we see. We see this thing essentially becoming owned by the community, controlled by the community. And at some point, Holo probably becomes not important anymore because if we're really successful, we've made the transition to an actual distributed applications world. But for us to launch Holo, we need hardware in the world. We need people actually sharing the capacity for storage and processing and bandwidth on their devices to serve websites out to other folks. We could run that on just people's laptops and desktops and things like that. But we felt that it was important that early on the ecosystem have a stable foundation, that there be enough nodes or participants in the network that were on all the time, that when somebody went to go use an app, it was there. right? It wasn't, oh, sometimes it's there and sometimes it's not, and hopefully one day it's not buggy. No, we want to launch this ecosystem and have it be stable, have that foundation be a solid enough foundation that the user experience for people who are accessing apps in this way is a positive one, so
Right.
that can then grow. And so we don't see we're basically doing a couple of things. There's a handful of things we're offering as perks in this Indiegogo campaign. One is a piece of hardware, the Holo port, and we've got 3 options there. Another is developer training, so people who are looking to build Holochain applications and are wanting to gain some guidance there, and some other things that are sort of the souped up version of that, a one-day developer camp for your company, some other things where you turn to us and you ask us for some consulting to help you figure out how to design an application for your particular use case, whether that's a peer-to-peer energy grid or a peer-to-peer alternative to Airbnb. And so we've got a handful of things, all of them focused on helping to foster an ecosystem, right? We're trying to plant the seeds to get an ecosystem to grow. We don't think that this is going to be enough, right? This is one of the pieces. We're also planning to do an initial coin offering. We're actually calling it an initial community offering because we're doing credits, not tokens. Our architecture is a little different than blockchain and all the other ICOs that have been out there. But we're making it so that the amount of currency that we're making available to the public is dependent on the participation in our crowdfunding campaign. We're looking for how many developers are signing up for trainings, how many Holo ports are being shipped out into the world as a signal for how large our ecosystem is going to be. And based on that, we're then going, okay, we can sell this much fuel. We can sell this much, what we call Holo fuel, our currency. We don't want to do $1 billion fundraise because, to be totally honest, we're not ready for $1 billion, right? We're ready to handle the next stage of development. This is supposed to be a step in a process. And we're not trying to get a bunch of free money. We're trying to bootstrap an actual vibrant living ecosystem. And so we're aiming for a $2.5 million ICO. It may go higher than that. But we're aiming for a $250,000 crowdfunding campaign, which fortunately in the first 5 hours we've managed to hit our 30% mark, thanks to people like you, Alexis.
Yeah, I've seen that. I've seen you have very cool, slick design with similar to the Mac Mini, as I've seen. Is that all of the products that you will deliver, or is that? Are you going to deliver more of the products once the Indiegogo campaign is finished?
I don't know the answer to that. Initially, we were looking at this as, hey, this is about us bootstrapping an ecosystem into being. That said, we have managed to partner with a really solid hardware company who has just been wonderful. And they have made this process really easy for us. They've been working with us for them. It's a passion project too. They're definitely not making a fortune off of this, but they see this as, yes, that's the thing that I want to bring into the world, right? And so they've just been wonderful, helping not only in the hardware design, trying to help with branding and certain things like that, not all of which are actually implemented yet. Not all of those are rolled out. So they may not be visible, but they've been a really incredible partner, and so we're looking at possibly doing more things with them in the future. We have beyond Holo and Holochain, we have a longer roadmap of things that we're wanting to bring into the world, and some of those involve hardware as well. So there may be some really interesting things in the next year or two, but those are probably not the story for today.
Interesting, and maybe I want to get to that also later in the interview. But right now, at the moment, we see many great blockchain projects rising. What do you think? What makes Holo and Holochain better than the previous systems?
Sure. The thing that makes Holochain better than blockchain, in my opinion, is pretty simple. Holochain is cheaper, faster, more scalable.
On point.
Not just a little bit, significantly cheaper, faster, and more scalable. Right now, Facebook does 500,000 likes per second, right? 500,000 likes. Blockchain, Bitcoin, we'll use the biggest, the granddaddy of the blockchains, right? Do you know how many likes or how many transactions Bitcoin can handle a second?
I see different numbers from 4 to 7.
Yeah, so let's give it the benefit of the doubt and say 10, right?
Okay.
So it's doing 10. So this is the gold standard, or at least the grandpa, doing 10 transactions a second. You've got another system that's doing 500,000 transactions, likes, of just one type of thing. You know, likes aren't the only thing that Facebook does. The reason for that slowness and the reason why blockchain is having a hard time handling scale is because the architecture itself requires every participant that's operating as a full node to hold on to every action that anyone in the community takes. That's an incredibly wasteful process. It was useful for solving a particular problem. The way that the founder of Bitcoin, the potentially pseudonymous Satoshi Nakamoto, had framed the problem, he was trying to create universal order, a universal agreement about the ordering of events. So he was trying to get a bunch of people who are in different locations, a bunch of machines in different locations that are actually seeing things happening in different orders, thanks to general relativity, right? Einstein first described this, there is no universal ordering of events. Satoshi figured out a way where we can randomly pick one party and we'll go, for this 10-minute time, we're looking at their ordering of events. And as long as it doesn't break any rules, everybody else will go, yeah, that's fine. But that has a bunch of costs. Having to come into agreement about the order of everything that happened means you have to one, keep track of everything that happened. Two, you have to communicate with everybody else about what has happened. Mm-hmm. And then because you're having to keep track of that, you have to bear the cost of all of that. So it makes the system slow, expensive, and having a difficulty handling a large volume of transactions. Holochain uses a different architecture entirely. And in part because we were trying to solve a different problem. We weren't trying to generate a universal ordering of events. And though that can be useful in certain use cases, it's not required as a basic need for doing any sorry, got some.
No, it's all right. Don't worry.
Universal ordering of events is not required for running a distributed application. Simple example, email.
Yes.
I don't have to know whether you received a message before Jim received a message in order for me to use email. I don't have to ever communicate with you, right? There's other people I'm communicating with. It may be important for me to know which order my emails came in, right?
Yeah.
But I don't have to know everybody else's orders. Email is a wonderful and familiar distributed system that does not use a universal ordering of events. Holochain, without going into all the details of the architecture, we used a couple of different tools that we didn't invent. We've combined them in a novel way, but we used a couple of different tools that have enabled us to solve this problem more efficiently. One, hash chains. This is actually one of the core pieces of blockchain. It basically solves the problem of, hey, I can put things in a record in order in such a way where if I change this one, it becomes obvious to anybody that I've shared this other stuff with that I've tampered with the data, right? So we call this an immutable or unchangeable log. So hash chains. A distributed hash table, which is the back end of BitTorrent and other systems like that. For those who are familiar with the blockchain and distributed computing space, they're familiar with IPFS. Right? These things are using a distributed hash table, which is essentially a really efficient way of sharing content in a community and not having everyone have to hold on to every piece of content and being able to find it very quickly. So it's a way of storing things, being able to have them be pulled back out, and have that spread across a bunch of users who happen to be popping onto and off of the network constantly, with enough backups and things so that you've always got some, at least one piece of this content online. And you probably have 5 or 10 or 20, depending on your application. So we took those two things and we combined them with one other thing, signatures. Literally, at the beginning of this application, I have a key, which enables, I create a key, a public key, private public key pair. This public key is shared with the world, and that enables 3 things. One enables me to sign things using my private key that other people can check and go, oh, it's the same guy that signed that last thing. Right? So that gives me some ability to communicate to others that I'm the same person taking these actions. 2, it enables people to encrypt things so they can send me private messages that no one else can read, where I'm the only one who gets to read them. And 3, it serves as an address in our distributed hash table, which is part of how the content gets routed and looked up. I don't need to go into all the details there, but the basic gist is we've taken these 3 things, a hash chain, which is my local hash chain. It's my content. It's the actions that I've taken in the system and the things that I've seen. A distributed hash table and signatures. And then we add to that the application code. The application code meaning the data schema, the structures, and the application logic, the validation rules, the things that are acceptable or not acceptable. And with that, you're able to run a fully peer-to-peer application. You're able to actually do a peer-to-peer Twitter. What would the validation rules be? It'd be something like, is it signed by who it's supposed to be signed by? And does it have more than 140 characters? It shouldn't, right? And so when I send a message on Twitter, it first records it locally and adds it to my hash chain. It then sends a piece of it, and I won't go into all the details of how this works, but it basically randomly sends the message out to... Please do go into the details. I can go into the details.
It's for me, it's very interesting, but yeah,
I can go into the details. So the basic gist is, for those at home who aren't familiar, a hash function is one of the workhorses of cryptography. It is one of the core things that we rely upon for all sorts of different things in computer security. And what a hash function does is it's basically a mathematical equation where you take a piece of content and you feed it in, and it spits out another piece of content, a really small one that happens to be a fixed length. So for simplicity purposes, let's say this is a 100-digit long number, right? No matter how big this file is, it spits out a 100-digit long number. And if you put the same piece of content in, it spits out exactly the same number. Okay, so with that being the case, if I change one space, it spits out a completely different number. Anybody who's familiar with blockchain is familiar with hashes, but for folks who aren't familiar, it's like, okay, that's interesting, but what does that do for me? Well, this acts as a digital fingerprint. And with that, we've come up with all sorts of different ways of using that to help us solve some problems. For us, we have public keys, we have content. The hash of my public key, I feed it in and it spits out this fingerprint. That becomes my address, my node ID in our distributed hash table. The hash of this piece of content becomes its fingerprint. And when we try to find where to put this, we want to put it near something that is close to it. We can compare these two things together because they're both 100-digit long numbers. And we don't exactly compare them in a normal way. We use something called XOR logic. I don't need to go into the details. But you do a comparison and you go, yep, this one is close to this one and far away from this other one. So let's send it to him. Right? And we look for the participants in the network, the nodes, that are closest to this piece of content. So we call this content addressability. Where the content goes is actually based on the content itself. It's based on the fingerprint that content generated. And so if this content, for simplicity, generated a 7, right, as its fingerprint, and we had 6 people in the network, and we had a 1, a 2, another 1, a 3, and an 8, right? Or something like that, right? I don't even know if that was the right number of folks. Where would the 7 go? We're going to hand him to the 8 because the 8 is the closest thing to him, right? And when people go, hey, where's 7? They're going to reach out to the closest thing they can find to a 7, which is 8, right? And so this enables us to both store content and look up content really quickly because we know where to look in the network. If I go even deeper, what's actually happening is you have this little store of addresses, and they've got 2 types of addresses. We've got the node ID, and we have their IP address. And we go, okay, who's got the node ID that's closest? Oh, this guy does. Okay, what's his IP address? All right. And then we send that over the existing internet. The protocol is called TCP/IP, and it pops around and gets to him, right? Now, the actual way that this works is we first query the network and we go, hey, who's closest to this? And then they send back, oh, these are the 3 people that I know that are closest. And then we query those people. And we find our way to the folks that are closest. And then we probably hand this thing to 5 different parties at once that happen to be close to that address. And each of those parties then checks their own copy of the rules. So one of the ways that Holochain works is every participant has their own copy of the rules. They're running the application themselves. And in their source chain, they've got the first entry is their application code, and it needs to be identical. If you're running something slightly different than I'm running, you're going to have a different fingerprint in that first entry. I'm going to compare those fingerprints and go, ooh, different fingerprint. You're not in the same app I am, and I'm not going to be sending information to you. But if they match, hey, we're in the same space. We should be playing by the same rules. Okay, I will share content with you. The second entry in your source chain is where we put the public keys, right? So that's where I would check to see, is this the guy who signed this? Or I would look to see how I'm supposed to encrypt something to send it to you. And so what ends up happening is when I send this content to you and it lands on your device then checks. Running the same app? Yes. Signed by the right person? Yes. How are all the other validation rules? Is it less than 140 characters? Or less than or equal to 140 characters? Yes. Okay, it looks like it checks out for me, and they sign off on it. They literally add their signature to a statement saying, this plays by the rules from my perspective, and they hold on to it. And when later somebody says, hey, you got this piece of content? They go, yep, and they hand it to them, but they hand it to them with their signature on it. Right? Saying, yep, this looked like it played by the rules, as well as any other parties who happen to have signed it as well when they checked it. So this is how we validate content, but we've got multiple parties validating content at the same time, and they're random parties, right? And so what happens is if I go, yeah, this actually has 160 characters, but it's only supposed to have 140, but I'm going to pass it along anyway. And so I've hacked my node in some way. So I sign off on this. When I pass that data along, the next party who gets it is going to, if they check it, or if they happen to have seen a different signal from someone else who checked it, like, wait a minute, this guy said it was not valid, and you're saying it is valid. And they also have their own copy of the rules, so they can check it. How does it check out? Nope, not valid. This guy's lying. This guy's either been, his disk has gone bad, he's been corrupted, or he's been hacked, or he's trying to do something bad. In either case, he's passing around unreliable data, data that we shouldn't be trusting. And so I will first, maybe I will block him. I don't want to receive any more stuff from you right now. And then I will warn others, hey, somebody's doing bad stuff here, right? And so this mechanism enables the community to actually have an immune system response without having to have everybody holding onto the content. Now, that said, the Holochain architecture is really designed to be a lightweight, sort of the lightest, smallest building block architecture. And we see for particular applications, people being able to add new layers of security on top of this, new things that give them greater assurance that they're not going to have a bad experience. There's a variety of tools in the toolkit. You could have something like you have to put $1,000 in an escrow account and you forfeit if you behave badly, right? that changes somebody's risk profile. If your average transaction in this context is a $5 transaction, you don't want to give up $1,000 to, maybe defraud somebody of $5. Okay, that's one way to steer or sculpt the game mechanics. Another is you've got reputation in other communities. And in order to enter into this space, you actually said, hey, look, I've got good reputation over here and over here. And you're bridging your identity between these different spaces. Well, if you now have exposed that you are the same party in these multiple spaces, if you start behaving badly over here, that can cost you elsewhere. So that's another way you're able to alter the game mechanics. And then a simpler one, which is one of the ones that we're actually using in Holo, is you're signing, we're doing a transaction together. I'm going to give you some credits. So my account balance is going to go down and your account balance is going up. And when we go to do that transaction, I sign it and you sign it, and we both add those to our own chains. And so on my chain, I've got your signature. In addition, you've got mine. And so if I try to cheat, you go, hey man, I've got evidence here. But beyond that, we will share those out to a pair of notaries. Some people who have well-established reputation, who actually have a business basically running for doing this notarization service. And they go, yep, checks out to me. And they share it with others in the distributed hash table as well. And so there are mechanisms for adding skin in the game for multiple parties to make it less likely for someone to cheat. Another simple example is going, hey, you can only do transactions that are worth less than $1. So if somebody does manage to cheat, they're only able to get away with $1 or €1 or one Holo. And so there's a ton of different mechanisms that you can use for sculpting the risk. But on the other side, because you're able to sculpt risk, you're able to get basically instantaneous settlement of simultaneous transactions, billions or potentially even trillions of transactions being processed by the network simultaneously because they're happening in a distributed way, with these parties paying attention to their own interaction, these parties paying attention to their own interaction. And we can do trillions of transactions that are maybe each worth less than 1 cent, right? 1/100th of a euro or something like that. And we think that those trade-offs in many use cases are going to be the right trade-offs to make. But it's going to depend on the app. And so the idea with Holochain is it's lightweight enough and it's flexible enough that you can do all sorts of things on top of it. You can add additional security and things like that on top of it. And they don't come without cost at all, right? Some of those add additional costs, or they add additional delays, etc. But you design those so that they're appropriate for your use case, for whatever the type of interaction is that you're attempting to facilitate in that application.
Okay. You've mentioned Twitter as an example, Facebook, the Facebook likes, and at the moment you're working with a lot of developers to create cool apps. So let's talk apps.
Sure.
What do you think is going to be the killer app on Holo?
I actually don't believe in the killer app. Because we think that what's going to happen is there's going to be the killer meta app.
All right.
So the killer app on Holo is actually the fact that Holo puts the user in the middle. So the way I like to think about this is the thing that drove smartphone adoption, at least in the United States, was Google Maps. Now, prior to having a smartphone, I had maps. I had a little book with street maps in the back of my car. It was called the Thomas Guide. And I didn't feel like I had a mapping problem, right? Yeah. I had maps. I need to find someplace. I look it up, it's okay. And I figure I go there. But once I had a map that put me in the middle, the whole game changed. It guided me every step of the way there. It made so I didn't have to think about it. It made so I could pull up other information as well. Google Maps got better later on with like hours and things like that. But the fact that I got put in the middle was a game changer. And as soon as people experienced that, they went, I can't live without this thing. And people are like, well, isn't it just a phone that's kind of like your computer? And they're like, no, you don't understand. It's different.
So you believe the experience that the user will have interacting with all of these apps that are currently existing at the moment will substantially change, and that will drive the Holo.
That's right. That's right. By putting the user in the middle, we shift the experience entirely. Right now, you run to an application, and then you run back out. And then you run to another application, and then you run back out. And then you enter another application, and you run back out. And every one of those applications has a business model that is based on keeping you on their app. So they're all trying to addict you and distract you. And so we live lives that are fractured lives where we all feel like we're torn in 1,000 different directions. Why? Because the internet that we've built makes it so the applications we interact with are trying to pull us each in a different direction, right? If you have an internet where you're pulling pieces of applications to you and combining them in ways that are useful for you, you're choosing to run an application that happens to operate this way, and you're able to, anything you can read out of that, you can write into this other app. You start being able to bridge between spaces. And we've experienced a little bit of this in the world, in the web today, right? I get an email and I can click a button and it adds something to a calendar. That's a jumping from one application to another. Or I post something on Instagram and it also posts to Facebook, right? But in the past, those applications have all been, those interoperability problems have all been in the hands of the developer. The company decides, yes, we're willing to talk to this other app. Not in the hands of the individual. We think that when it becomes in the hands of the individual, what you'll start to see is micro applications and meta applications, little lightweight things where it's not a single rideshare app. It's one layer of a rideshare app, another layer of a rideshare app, another layer of a ratings system for does his car smell bad, and another one for is his music too loud, and somebody pulling all of those into a single user interface that to them seems like it's just one app. But on the back end, it's talking to different subsets of the community. And that enables me to customize my experience in ways that work for me, that pay attention to the things that I care about. You to customize your experience in a way that works for you, and for us to both still be able to interact. We think that's a really key differentiator. Will there be some early applications that get widely adopted? Yes, we think Holo is one of those, right? Holo is obviously intended to be something that's a utility app that lots of other applications make use of. The kinds of things that people are, if I dive back in more directly to answering the question that you asked,
yeah,
a lot of the folks in our communities are excited about apps that are really focused on collaboration.
Okay.
They're focused on how can we as a community coordinate our activity together more effectively? How can we do more fluid forms of coordination and collaboration? How can we do things like Airbnb, but run by us, right? A cooperative of some sort. How can we do things like an electric grid where I've got a solar panel and he has a windmill and this other person has a little thing with water and we've all got batteries and we're sharing electricity. We're trading it back and forth, maybe selling it to one another. Those kinds of applications people have wanted to do for a long time. They're difficult to pull off. And in order to pull them off, you need the value of your transaction to be worth more than the accounting cost for keeping track of the transaction. And when you're doing things like hosting, a little tiny bit of work that your computer does, or some electricity, right, transfer, it may be that there's only a penny worth of value in that transaction, which means you have to have an accounting system and a payment system that's able to profitably keep track of that for less than a penny. If it costs me 10 cents to keep track of the fact that you did 1 penny worth of work, well, that's not going to be very useful, is it? Right? We're not going to use that for helping account for and foster a flow of activity. the design of Holo and Holo Fuel, the cryptocurrency that we created, again, is really efficient. It enables for this very low cost tracking and settlement of payments of low value exchanges. And so we think there's a bunch of applications around sharing economy type apps that are going to be new and interesting. People are going to do peer-to-peer communication stuff. They'll do Facebook and Twitter. There are some network effects at play in those communities at present. So we'll see what the adoption is. My assumption is that's not going to be the thing that takes off right away. I think some of these other applications are going to be much more quickly adopted.
Wow. So this all seems really interesting to me, and I would love for me personally to go more into the technical part, but for the sake of the interview, I'm going to keep it.
Tell me what is, because I can cater this to what you need. What's the soundbite that you need? Do you need a short thing? Do you want a long thing? Do you want the 30 seconds of blah? What's appropriate for your format?
I think you're doing a pretty fine job to have the balance between finding the keywords that are important for us, plus a little bit of a detailed explanation for people who are interested longer term. Everyone else, they can skip the parts that they're not interested in. But I am really interested myself in it. So another question is, like, since we're talking about how is Holo developing and where it's going, so we look into the future of Holo. I know, or correct me if I'm wrong, Holo is a stepping stone towards the bigger project Ceptr. Mm-hmm. What is the long-term vision for Holo? Is Holo going to be subsidized later, or
subsumed, drawn in? I don't honestly fully know how that ends up playing out, right? Like, I'll give you a little bit of the backstory. So Ceptr has been around for a while. Our group is called the Metacurrency Project, the group that this is all coming out of. And the Metacurrency Project has been around for about 10 years. Not all of us have been on the team for 10 years. I've been working and pursuing distributed applications, specifically focused on how communities can self-steer, for about 12 years maybe. But I didn't join the Metacurrency Project until about 3 or 4 years ago. I had been looking for other people that were doing this kind of work. I had left a job running an investment firm to go. I'd had this vision of how you could change the structure of the internet and how that would change how communities steered themselves. And I was like, that's my life's work. I need to go do that. But I didn't know if it was possible, right? I had a wealthy business mentor who I was working for. And when I said, hey, I want to shut down the investment firm to go see if this change the internet, change society thing is real, he said, do you want some help? How do you want to do that? And I said, I want to go and just explore it on my own for a while, because I don't know if it's real. I wasn't familiar enough with cryptography to know whether or not you could pull something like this off. It felt like it was what we needed, but I wasn't certain it was actually doable. And I stepped away. I ended up living in Indonesia for a brief period to wash off burnout. I landed in San Francisco. I started a community called Build the Collaborative Internet. And all of a sudden, I found my fellows. I found all of these people who were looking for these kinds of answers and were trying to build them. And we're interested in, content addressable networks and hashing algorithms and, all of these things. And they were security folks and privacy folks and democracy advocates. And, there was this really interesting blend of humans that sort of pulled together into this community. And I got to do some fun projects with a lot of those different people, but I still wasn't able to find anybody who was really solving what I was looking to solve, which is, how do you enable a community to actually self-steer fluidly, organically, and persist, to have a real adaptive capacity. About 4 years ago, I met Arthur Brock, and then got introduced to Eric Harris Braun. And those were the co-founders of the Metacurrency Project. And when I chatted with them, I went, I think they're trying to solve the same problem. And as I chatted more, I went, not only do I think they're trying to solve the same problem, they've got the chops to pull it off. right? Because I was learning my way through computer science land over the course of 5 or 6 years, but they had basically been raised in it, and they'd had full careers. They'd run software companies. But not only did they have the software side, they had the philosophical underpinning as well. They had also dove into the organizing patterns of nature to try to tease out, well, how is it that these things really work? And then they went to apply those to their architectural designs. And so when I tried to poke holes in what they had, proposed and said, well, is it like this, or does every time they answered in the way that I had concluded also. And I was like, okay, I think they're doing it right. I don't need to build my own thing. I'm going to go join forces with them. And so me and my business partner at that time stopped trying to do our own thing and went, we will volunteer on this full time. And so we had set up a company, and the purpose of that company was to subsidize our distributed internet habit, right? It was to make it so that we had enough money to eat and put food on the table that we were able to go and work on building these systems. The Metacurrency project for the last several years has worked on something called Ceptr, CEPTR. And for those at home who are not afraid of going into the wilderness, there's a whole bunch of interesting and very difficult to understand things in Ceptr. You can dive in. Ceptr.org is the website. One of our problems with Ceptr is that we're so far out on the edge that in order to understand what you're doing, you kind of have to break your brain 12 different ways. Right? There's all these assumptions that we have about how the world works that Ceptr sort of challenges. And we think that those things are right. That's, we kind of landed, these were like a series of epiphanies that, I didn't realize that's how this works. I didn't realize that. But once you end up applying all of those things, you build something that looks very foreign. And it's like, well, why would you do it like that? We were basically trying to build a computing system or a new way of doing networked computing that mimicked biology, that mimicked natural systems. We had been working on that for a while. We were making some solid progress. And one of the members on our team had a family member who had a health crisis. And our team sort of went into a hibernation period for a while as a loved one was passing away, basically.
Okay.
And when we were getting ready to kind of come back online, when it was looking like, okay, we're about to start working again, we had a conversation that basically went, hey, we've been building this thing and we've got this vision. It's got a lot of different puzzle pieces. And we know what the next puzzle piece is. It's this distributed data integrity layer that we had already mapped out, but we hadn't yet started coding. What if we built that as a standalone thing? What if we built that as its own little module? And just like the rest of our stuff, it's open source, but we did it in languages that people are excited about now, and we make it easy for other people to start playing with. Maybe that would get other people able to see what we're up to and start being excited about playing with this space too. And we realized, hey, everybody at that point, this is late last year, everybody at that point was already excited about blockchain. I was doing a lot of consulting work for Fortune 500 companies, guiding them through blockchain things and going, hey, blockchain's not the future, but guiding them through saying, hey, there's some useful stuff here and it doesn't solve all your problems. And so we went, hey, you know what? Let's do this. Let's put it out in the world. Let's position it as it should be. This is not blockchain. It's an alternative. It solves things that blockchains can't solve. We think you're going to find it useful. And let's put it out in the world and see if we can get an ecosystem to actually form and begin doing interesting work and building things, because then you're started. And then we won't be building our stuff on our own, right? We'll have a bunch of other people building really interesting things. So without going too far into the details, I'll maybe move one step into the future. So okay. Holochain is distributed applications, right? Holochain is you and I running applications that work the way that I want them to run and you want them to run. And the reason that we're using them together is because we both choose to continue using that application together. That's a little different from how today's apps work, right? Like Facebook is take it or leave it. You don't get to change it. You don't get to choose. This is a little different. This is like, I don't like how this is working. I want to change it. And if other people want to play in that new space, cool, we can do that too. We can also have some mechanisms for speaking across versions of an app, for instance, or across different apps altogether. So that's Holochain. Holo, as I'd mentioned before, is really about bridging between this distributed or peer-to-peer application context and mainstream internet users through a web browser. People who want to just go to a web browser, they hit, ourbnb.io or whatever, and they click book and they book a room. And on the back end, it's all distributed and run by the hosts themselves, the people who are renting out rooms, let's say. But on the front end, they don't know any better. It just looks like everything else they've ever done on the internet, and that becomes the toe in the water. And then they may be actually able to go, well, we can do this. We can give you a discount if you actually install the app or whatever, and you start running Holochain. So we have ways of people to be able to begin being onboarded into that space. And then the next piece that we're probably building after that is one that we've previously built, but we've built it as part of our sort of larger monolithic Ceptr project. And when we rebuild it, we'll be building it in a different language and as its own separate modular thing that people can take and grab and play with. So,
do you have a name for that?
Right now, we call it the Protocol for Pluggable Protocols.
Okay.
Or P cubed. Yeah. Right? So P3. P3.
Okay.
What is a protocol for pluggable protocols? It solves interoperability. It's a mechanism by which one protocol or API can be bridged to talk to a different protocol or API easily and quickly. And it's not about it being no work. It's going to be work. It's actually about reusing work. It's about being able to create Lego blocks that on one side fit one thing and on the other side fit another thing, and being able to go, okay, we're going to do this transformation. And so this is an address. There's some protocol here that involves at some point an address. And the way that they do address is address, city, state, country, right? Or city, state, zip code, or something like that, postal code. And the way that these guys in this application do address is city. That's it, right? When you've got information coming this way, there's probably a pretty simple bridge, and it's going to look something like, get rid of everything except for city. Because from this application's perspective, all that other stuff is noise. The only stuff that's signal is city, right? If you're taking content in the other direction, you're going to have a different choice to make. You may decide, do I leave these fields blank? You may go, well, for country, we can intuit what that is. For postal code, we might even be able to figure that one out. For address, no. So do I leave it blank? Do I put nothing? Do I literally write the word like there was no content or null? Or do I actually enter the center of the city, or city hall or something like that? And that's a decision that gets made. But once you've got some of those bridges, you're able to go, grab that one, grab this one, grab that one, and connect some applications together. And the way that P3 works, or P cubed works, is once you port one application into this semantic space, this Ceptr space, and you port another one in, it becomes very easy for them to talk to each other. But it also becomes very easy for them to talk to any of the 100 or 1,000 other applications that are also in this space, right? And
do you?
Yeah.
Let me interrupt you really quick. Do you have any website or any resources where our readers can read more about P3?
Yes, if you go to ceptr.org, CEPTR.org, you'll be able to look up P3 there. And we actually have some demonstrations online. Mostly we've talked about this as semantic trees. So part of Ceptr's architecture, without going too crazy into the weeds, in order to do Ceptr, we had to rethink how computers worked at a very low level. So in normal programming languages and normal computing programs, you generally have bits, right? These like ones and zeros, bytes, like little groupings of those, and then words, right? So it's bits, bytes, words, and that's kind of like the step size up of some your basic building blocks.
Okay.
For us, we changed that to bits, bytes, semantic trees. And so in Ceptr, we're using semantic trees as our basic data unit. It's how content gets stored. And what that means is you're not only holding on to a piece of content, you're holding on to it in relation to other content. So it's content in relationship, which means that you can't actually store just 7. You can store a size 7. You can store 7 seagulls. You can, right? But you can't just store 7, because 7 would be something that doesn't have its context. So it's an associational way of thinking about data. That gives us some real advantages when it comes to how Ceptr operates. Ceptr has these lightweight virtual machines that you can spin up and shut down, and it's a machine that does just this one job, and it sort of has a membrane. It will only accept certain inputs, and then it does some transformations on those, and it only lets out certain outputs, right? So anything that doesn't fit that can't cross the barrier. It's not able to pass through. That ends up operating sort of like cells in a body, right? We think of these as being membranes that are basically judgment layers about what can come in and go out. Well, it becomes important for you to be able to have a virtual machine. We call them receptors. To have a receptor ask for something, send out a query, hey, I need something, and it's waiting for a response. While it's waiting for a response, you want to do some other work. So it's important to be able to put that thing to sleep and set it aside. Do some other things, you get the response back, okay, wake him back up and start going. Well, it was important for us to be able to do that dehydration and rehydration, or parsing and lexing, etc., almost instantly, which meant we wanted to have the structure maintained even when it was written back to disk, right? So when you come back up, you're immediately able to do stuff with it. The other piece that semantic trees make useful is when you're handing something to someone, you're also giving them the clues about what the context was that you were seeing this from. And they can go, I don't understand, and they can ask for more context, and you can hand them some other bridges. And at some point you get to a place where they're like, ooh, okay, I've got the parts that I needed to now make sense of what you've handed me. This was a really key insight for our team that led to a lot of this design work, and it was that it's very important to be able to receive a message, to receive a signal, not know how to interpret it, to then be able to go look up the interpreter, then interpret the signal, not having to ask for it to be sent again, right? It's important for you to be able to hear a word, not know what it means, then have me use some other words to describe it, and you go, oh, I get it, and be able to put it together in your head. It's how language works. We describe this as receptive capacity, and your ability to add new protocols. If I use a word like holographic storage, right, that might not mean anything. If I then start describing it as, oh, holographic storage is actually how language is stored. Each party, each participant holds the information, holds the protocol from their own perspective as influenced by their experiences. So you and I both speak English, but our versions of English differ. I'm a surfer. I have jargon that involves surfing, right? Like offshore wind and air reverse, and I got tubed, bro, right? Okay. And some of those might make no sense to you. And you'll have other jargon that I won't understand, or maybe whole other languages. We are able to communicate despite the fact that we are not in perfect alignment. Sometimes we have mistakes in communication, right? Sometimes I say a word and you don't know what it means.
Yeah.
And I have to use some other words to try to build additional shared overlap between our two mental models. That's the cost of holographic storage. But we think the advantage is profound. We think the advantage of holographic storage is that one member of a community can go try something new, a new word, a new path, some new food. And if it proves badly, well, it was just them at risk, not everybody. It was their time, not everyone's. But if what they find is useful, maybe they start using it. and they share it with the next person. They go, wow, that's really useful. And they start using it, and they share it with the next person. Like, wow, that's really useful. And it can propagate across potentially the entire community. But its propagation is based on each new participant going, yes, I want to do this dance more. This is useful for me, and choosing from their experience that this is something they also want to participate in. So we think holographic storage is actually the key to adaptive capacity, because it enables a community to get the maximum amount of learning for the minimum amount of risk, right? One ant goes and explores over here. Ant got squashed. The rest of the colony's still okay. One ant goes explores over here. Ooh, ant found some food. Comes back. Ooh, more ants found some food. Oh, the whole colony gets to eat.
All right.
Right? It's how nature does data storage and social coordination. It's how we do language. It's how we do culture. You hold your culture, your expectations about what's right or wrong inside of your brain and body. We internalize them. It's what enables culture to change and adapt. It's what enables language to adapt so fluidly, is the fact that it's held holographically. It's not yet how we do it's not yet how we do communications online. It's not how we do digital applications. It's not yet how we do organizations. Many of us think of organizations as if they're guided by rules, laws passed in a government, or memos and orders handed down in a hierarchy like a corporation or an army. But anybody who's ever worked in an organization knows that, yes, that's the fiction, but that's not how it actually works.
Mm-hmm.
The way it actually works is sometimes the people upstairs say, honesty is very important, and they write it on the wall. And everybody in the office goes, yeah, right. Those guys would steal your grandma's, right? And they don't believe the words, and they internalize a different value set, and they continue doing dishonest stuff, right? Or vice versa.
Yeah.
And sometimes somebody shows up and they go, no, I really mean it. And they start to live it. And other people begin to shift their expectations about what is appropriate. Culture is fluid, and it is held locally by each of the individuals. Language is held locally by each of the individuals. We believe that applications also should be held locally by each of the individuals. And that the ways in which an individual decides to constrain their behavior in order to participate in a community, that also should be held in that same way. So that individual gets to go, yep, those are the rules I want to play by. I recognize that they take away some of my freedom, but playing by those rules actually enables me to do something really rich with this community, right? I know I'm not able to drive on the wrong side of the road.
Yeah.
That takes away some of my freedom, right? If I want to drive in Germany, drive on the left or the right?
And no, on the
You're
right.
on the right.
On the right, yeah.
I want to drive on the left, right?
Yeah.
Your rules about driving on the right take away some of my freedom. And yet they enable everybody to drive really fast because we're not having to go, oh, some people are on this, are coming the wrong way. And so us coming into agreement about that gives us some benefit. And that's the case with all of these things. But we want people to be able to choose those rules and to be able to learn from their experiences, to go, hey, I tried this. It wasn't working. I'm going to try something different. And for other people to go, hey, I tried this. It's awesome. I'm going to keep doing that. And you might want to try it too. And we think that that's how communities actually learn. We think that's how organizations actually learn and adapt. And so for us, this stuff is really just a big ploy to try to enable a world with much more fluid and adaptable forms of organization. Because we believe that the challenges that we face are so complex that the only way we have a chance at succeeding is if our social organisms, our corporations, our governments, our community groups end up being able to adapt in these fluid ways so that they can outpace the challenges themselves, right? That they can out-innovate the complexity of the situation that they're facing.
Oh, wow. Oof. This sounds very interesting. And the P3 topic is something that I have to look into more and more in depth. I think we kind of reached the end of this interview, but before I want to finish this, first of all, I want to thank you very much for taking your time.
Thank you.
And as a last request, what can I do to join this big revolution?
Sure. There's right now we've got two main ways to participate. One you can do now, one you won't be able to do for another month. Today, you can go to Indiegogo.com in any country that it's served in and look up Holo host. And I think most of Europe has Indiegogo. Look up Holo host. That's our crowdfunding campaign. You can also go to holo.host and you can sure find a link to our crowdfunding campaign there. And either buy one of our Holo ports, or if you're a developer, sign up for one of the trainings. You can also join our Mattermost. We've got a Mattermost link on our website. That's sort of an open source version of Slack. So this is a community channel. We've got a whole bunch of people having conversations about the applications that they want to build. And they're sharing ideas, and they're actually pairing up and working on things together. So those are the things that you can do right now. In about a month's time, we are going to be launching our initial community offering. So we're going to be doing an ICO where our target is to raise 2.5 million euro, I believe. That ICO is limited. We are going to be doing that in Europe. We're going to be doing that not in the United States, not in any of the jurisdictions that have said, hey, we're not certain about ICOs. We're trying to be regulatory compliant in every way we can. And one other thing to note about that initial community offering is that it is going to be tied to the crowdfunding campaign. We want that offering to be enough for us to launch the network and not some crazy amount of funds that cause us problems, right? Okay. So we are trying to grow our community of developers and hosts and users, and we want to make sure that there's enough financing available for us to adequately service that community for the next year and a half, 2 years. That won't be the only things we do over that time. We're looking forward to P3 and other things like that. But yeah, so if you want to participate, Indiegogo.com, look up Holohost, go to holo.host, look up our Mattermost channel there, sign up for our newsletter, and then in early, I believe it's the beginning of the second week of January, we're going to be doing our initial community offering.
Wonderful. Thank you again.
Alexis, thank you so much.
I wish you a pleasant evening.
Wonderful. And we have regular conversations online. We're doing Q&As regularly on Facebook, as well as some other channels like Zoom. And we're going to be doing a series of community conversation things where we publish some interviews or some articles, and then we ask other people to have conversations, and we ask others to sort of share the highlights. So we're trying to actually foster a much broader exploration of this space as well. So that's probably too many things.
Cool.
But
as Holochain and Ceptr progresses, Crypto Ticker plans on keeping everyone posted about the progress.
That sounds awesome. Thank you so much.
My pleasure. My pleasure. I wish you a pleasant evening.
You too. Take care.
Goodbye.
Bye.